Question 16 is assessing our ability to generate functions or recursive definition for arithmetic sequences. Question 16 reads, Savanah just got contact lenses. Her doctor said she can wear them 2 hours the first day and can then increase the length of time by 30 minutes each day. If this pattern continues, which formula would not be appropriate to determine the length of time in either minutes or hours she could wear her contact lenses on the nth day? Okay, so in this particular problem, we are looking at an arithmetic sequence. How do we know that it's an arithmetic sequence? If you look at the growth pattern, it says it um, increases by 30 minutes each day. So if you increase by an amount, that's an additive relationship. So when you're adding a constant over and over again, that is an arithmetic sequence. Okay? All right, so what we're going to do is we're going to generate the first 3 terms of the arithmetic sequence in minutes and hours, and then see which of these, either functions or recursive definitions, does not generate the 3 terms that we found. Okay? All right, so let's start with the minutes term first. So she started with 2 hours the first day. Okay, so if she started with 2 hours the first day, that means the first term, A1, is going to be 2 hours, or in minutes, we know we have 60 seconds, 60 minutes in an hour, so 2 hours is equivalent to 120 minutes. Okay, so the first term for her sequence is going to be 2 hours or 120 minutes. The second term will be an increment by half an hour. Okay, so A2 is going to be 2 plus half an hour, which is 30 minutes or 0.5 hours. So 2 plus 0.5, which is 2.5 hours. Or if you want to write this in minutes, is going to be the previous term, which is 120 plus what? Plus 30. Okay, so that's going to be 150 minutes. All right, so the first term is 2 hours or 120 minutes. The second term is 2.5 hours or 150 minutes. And then the third term in hours, do you see what it's going to be? In hours is going to be 2.5, the previous term plus 0.5. Write that correctly. 2.5 plus 0.5. And that will yield 3 hours. And how many minutes is 3 hours? 3 hours is 3 times 60, which is 180. Or we can just follow the pattern of the sequence and just add 30 minutes to 150 minutes. And we have 180 minutes. Okay? So the sequence under consideration here is, in minutes, is going to be squiggly 120, 150, 180, and the pattern goes on and on and on. All right. If you want to write it in hours, it's going to be 2 hours, 2.5 increases by 0.5 hours every time, 3 hours, and then it goes on. Now we have 4 combination of recursive recursive definitions and functions to generate these terms. And out of these options that we have right here, one of them will not work. All right, so let's see which one works and which one doesn't. Let's start with option 1. So for option 1, A1 is 120, and this is a recursive definition. You get the next term by adding 30 to the previous term. Does not look like it's going to work here. Well, looks like it because this term grows by 30 minutes every single time. Okay, so let's generate the term. The first term, A1, is 120. For the minutes, that's a check. That's good. The second term, A2, is going to be the previous term, which is A1 plus 30. And then A1 is 120 plus 30, and that's 150. We have a match, check. And then A3, for A3, you take the previous term A2 and add 30. All right, so the previous term is 150. Add 30, 180. Ladies and gentlemen, it looks like we have a winner here. Okay, this looks good. Well, we don't have a winner because we have three winners. So this looks good. Now let's move on to option 2. Remember, the question asks for which one that is not going to be appropriate. So we're looking for the one that fails. All right. For a2, we have a function. An is equal to 90 plus 30n. Let's test it out. So for the first term, a1 is simply going to be 90 plus 30 times 1. A1 is going to be, we're going to PEMDAS this, order of operations, 90 plus 30, which is 120. Check. Why do we have a check? Because that's the first term here, 120. We have a match. A2 is 90 plus 30 times the n. The n in this case is 2. Okay? Now if we work that out, we have 90 plus 60. 90 plus 60 is 150. Does that correspond to the second term? Yes, it does. Check. It looks like this one is good also. Let's try the third one. So A3 is going to be 90 plus 30 times 3 because n is 3 in this case. Using your order of operations, multiply first before you add or subtract. 90 plus 90 is 180. Check. Question 2 is good. All right, so question 1 is good. Question 2 is good, which means they are not what we're looking for. Remember, we're searching for the one that does not work. All right, A3, option 3. Option 3, we have a recursive definition again. A1 is equal to 2. Now we're looking at hours, and the next term is defined by the previous term plus 0.5. Do you think this is going to work? Absolutely, because that is exactly what this sequence is, right? Well, let's look at it. So A1 is 2. That's the first term for the hours sequence. Check. A2 is the previous term A1 plus 0.5. The previous term is, what is it? 2 plus 0.5, which is 2.5. Are we surprised? No, because this recursive definition is exactly what this is. And then A3, what's A3 going to be? 2.5, the previous term, plus the growth factor, the common difference, 0.5. You get 3. And that's exactly what the third term is here. So we can clearly see that option 3 is a formula that will be appropriate for determining the nth term of any nth term here for this sequence that we have. All right, so since A3 works nicely, that means it's not the answer. Then our answer should be option 4 by elimination. Okay? All right, let's verify to make sure that it is correct. So for A4, we have a function again. So an is equal to 2.5 plus 0.5n. Okay, so the first term, let's test it out. A1 is going to be 2.5 plus 0.5 times 1. We're going to use the order of operations. Please excuse my dear Aunt Sally here. 2.5 plus 0.5. 2.5 plus 0.5 is 3.0. Is this the first term in any of these sequences that we have here? Most likely the arrow one. The answer is no. This is wrong. So since this is wrong, the first term is already wrong. That tells us that option 4 will not be appropriate to determine the length of time in hours for the nth day. All right, so the answer to question number 16 is option 4. So which one do you prefer? Do you prefer the function representation or recursive definition of arithmetic sequences? Let us know what you think. You can place your comments in the comment section below and let us know your preference and why you prefer that.